Tech Lab at the Science Center. Today we're going to be exploring all things lasers. So we're going to explore our laser cutter, we're going to see how the laser cutter works, and how we go from a digital design into a physical product, similar to what we did with our 3D printing video. So if you're ready, we'll get started. So this machine here is our Glowforge Pro. We also have a Dremel down at the bottom. What we're going to be using today is the Glowforge though. It's a very simple, user-friendly tool that allows you to dive right into laser cutting with not a lot of background knowledge. That's why we went with this for our first machine. It does come with a high price tag, but it is an excellent machine and has great qualities and features. So the Glowforge Pro, once you open up the door, you can see a glass tube back here, and that glass tube is actually what produces the laser. So this is a CO2 laser, and it's not the most powerful laser, but what it will do is cut wood. It also cuts acrylic, and you can even engrave into aluminum. So things like a MacBook or your iPhone, you're able to engrave into those materials. So this glass tube, again, produces that laser. And then right on the front here, this is the focusing unit. Now this takes that light that comes from the laser, which is not a very focused beam. It actually allows it to move a lens in the middle here up and down to focus that beam, so it's really precise, and we get a small kerf. So a kerf is the amount of material that is lost when you're cutting something. If you have a larger kerf, that means that you're going to be burning away extra material. If you have a very small kerf, you're going to be cutting only the material that you intend to. So this focusing unit is very important for the operations here. So if we look at the tube, we can see the laser tube is sideways here. So how does it get down to the material that we actually want to cut? So over on the side here, there are actually two mirrors at 45-degree angles. So this light that comes out of here is bounced off the first mirror and then bounced off the second mirror into the focusing unit. Now this focusing unit can move in the x-axis, and it can also move in the y-axis. And just like the 3D printers that we talked about, those are controlled by these stepper motors. So the stepper motors can be very precisely controlled. And in fact, that's what we're going to look at when we create our individual images to be able to cut on here. Alright, so before we can begin burning things with our laser, we actually need to figure out the software side of things first. So we need a virtual document to be able to send over to our laser, that way it can create a physical object for us. So we're going to look at two programs today, two of my favorite programs, and in my opinion, the easiest programs to create these files for the laser cutter. So we're going to look at a program called Inkscape, and this works with 2D images. Then we're going to look at Fusion 360, which works with 3D images. And Inkscape is totally free. It's an open source program. I'll make sure to leave the links down below for both of these. The second program, Fusion 360, you can get a 1-year free trial as a hobbyist, and then you can get a 3-year trial as a student. So we're going to start off by looking at Inkscape. So you're going to want to open up Inkscape, go into File, and import the image that you want to cut out with your laser, or in some cases you can engrave or score, but we'll talk about that when we get to the laser cutter. So I've downloaded our logo here, and as I open it up, I want to make sure that I click on the link button here. So that's already selected, and you can see our logo in this case is really large, so I'll zoom out so it's centered on the page. And if you would like to change that page size, all you have to do is make sure that you have your image selected, go up to File, Document Properties, and then you're going to change the page. So you're going to resize page to content and click this button right here, and you can see in the background it resized it to that image size. So not entirely important, but if it helps you, it looks better on the page when it's the correct size. With our image still selected, we're going to go up to Path, and then we're going to click on Trace Bitmap here. So what this is going to do is it's going to trace around the image as best as it can. So right now you can see if I click update, it's only tracing that small portion of the image. And if we close out of this, or move it out of the way, we can see that it's selecting only this area here. We want it to select multiple areas, and in fact, we want it to get the entire image. So what it's doing right now, it's looking for brightness on the image. And if we raise that brightness threshold, we'll raise it up to about 740 there. We click update. You can see now it's selected all of the image as well as the text over here. So we're just going to click on OK. We like the way that that looks. And what that's done in the background, it's created that image. So I'm going to close out of this now. So you can see we have our new image, and just behind it, we have the original. What you'll notice about this image is there is no background, and that's exactly what we want. So we're going to move this over to the side, and we're going to look at the differences between these two images. So if I zoom in on the Science Center logo, this is a PNG image, which is similar to a JPEG, and as we zoom in on it, we can see that on the edges, we have lots and lots of pixelation if we zoom in really, really far. So that is a high quality image, and with PNG images, you can also have the background removed, and in fact, this one does have the background removed. But with the SVG images, if I click on it and zoom in, you can see zooming in way down, all the way to the highest resolution possible, we don't see any pixels. And this is a property of those SVG images. So SVG stands for Scalable Vector Graphic. And if I click on this node tool here, you can see all of those points that pop up, and those are nodes. And you can actually manipulate these and change the image by dragging them around. So I want to keep mine in that original format, but you can see what this will do is actually trace from this node to this node, and it knows the exact path that it needs to take. So no matter how large I make this, it will still have the same quality. So if I zoom it in, make it much, much larger, we can still see it has those really sharp edges. So I'm going to bring that, scale it back down, and now let's try that with the PNG image here. And zooming in shows, again, those pixels down there when we zoom in very close. So I'll bring that back down. And for the purposes of our laser cutter, we actually don't need this image anymore. So I'm just gonna simply click delete on the keyboard and get rid of that. So once we've done that and converted this into an SVG image, we need to make sure that we save it as an SVG image. So we're gonna click save. And I'm just going to save it to my desktop here, and we'll put it as SFSCA logo. And we'll know that it is an SVG image by the tag here. And you can see there are multiple file types that you can use. I like to stick to the Inkscape SVG because then you can bring it back into Inkscape and edit the object later if you need to. So I'm just going to hit save. And then we can close out of this, and we'll come back to that image later on. Okay, so what we're going to do here is we're going to look at Fusion 360 as promised. And in this case, we're not going to go fully into the design process. I'll put up a time lapse, that way you can see what exactly went into it. But it is a pretty involved process in creating an object like this. But what you can do is download a three-dimensional file, usually in the STL format, to be able to bring it into Fusion 360 and then convert it into the SVG, which is what we need for the laser cutter. In this case, I actually custom designed this as a Grammy Award for a music camp that we did here at the Science Center to be able to laser cut. Now, the benefit of laser cutting is it's much faster than 3D printing, as we'll see here in just a couple minutes. So now that I have the file that I want to convert into that SVG image, I'm going to go ahead and go into my tools, and I've downloaded already this Shaper Origin export utility. Now to do that, you just go into add-ins, find it in the Fusion 360 App Store, download it, restart Fusion 360, and you'll have it right up here. So if I click on the export to origin, it's going to ask me which shape do I want to export. And what you'll notice is it only highlights the faces of the objects. So I can select this face or this face, but obviously those are going to do me no good. So what I want to do is select the flat faces here. I'm going to click OK, and then you'll see it gives you the file type as SVG. So I'm just going to save that as the horn for the Grammy right to our desktop and click Save here. Now the reason that we want the two-dimensional image from this is because the laser cutter works only in 2 dimensions. It only has the X and Y axis. If you remember in the 3D printing video, I said it has the X and Y axis, and then it has that Z axis, which gives us the 3rd dimension. So you can create a 3D model with the laser cutter by stacking those images, or in this case, what I did here is I created a box to be able to give us a 3rd dimension right here when these 2 sides, or sorry, these 4 sides are snapped into place. And then obviously our horn at the top gives us that final 3-dimensional piece to our Grammy here. So we're going to go ahead and get ready to cut. Now that we have all of our files ready, we can go over to the Glowforge software. This is web-based, which is really nice. It allows you to run everything over the internet. You can run into problems at times if it's not connecting to the internet or if you have an internet outage. That is one issue that you can run into, but otherwise it's a very smooth workflow on it. So I've opened up a new project here, and I'm going to set my material, and I'm going to choose medium ash hardwood. That's the closest material that I've found that works with the boards that we buy. They are actually birch, but the material that we get is a little bit thicker than what they have set their standards at. So I'm going to click on the plus sign here and upload. And you can see all of my files down here at the bottom, and it says they are Microsoft Edge HTML documents, and that's simply because I haven't set those to open with Inkscape. Otherwise it would show it as an SVG document, but I know the SFSCA logo is what I'm looking for, so I'll click that, and we'll see it's probably going to be really large. Yep, it is a very large file here, so I'm going to shrink it down. And if I wanted to make it the exact size that I needed, I could have done that in Inkscape by changing the dimensions to precise size that I need. So the Science Center logo, we'll put it right there. And we want that to go onto the top of the Grammy. So I'm going to look for that top there. And once that opens, I know that is the orientation that I want there. So I'll set it over to the side, and I'll set it right down in the middle there. So you can see it highlights everything in pink because it wants to engrave it. Really what we want to do is actually cut it, and it'll show those outlines of where it's going to cut. So I'll set that there. I'll grab the bottom and set it right next to it. And we're cutting on 3mm birch plywood, and that's about an 1/8 inch thick. And we also have the material is 10 inches by 10 inches. So it's a 10 by 10 square. That's what we were able to find to be able to work with our laser cutter. They do have larger materials. 12 by 12 is ideal. Just right now with everything going on, wood is a little bit harder to find. So we'll get the back and the front on here as well. And when we're cutting, we try to use as much material as possible. So you can see I'm going to try to fit everything on here at once. That way we're not leaving any spaces that are kind of weird. So there's the front. So for example, if I left this empty, it's material that may go to waste. We do save all of our scraps if we have something smaller to print later on. So what's really nice again about this machine, it shows you that layout with an actual image on the of what we're actually going to be cutting. So there's a camera in there facing down, and you can see it, and it'll all fit perfectly in there. So I'll hit print here, and we'll see how long this is going to take to cut. So I'm actually going to change that logo before we do that to score. So scoring, what it does, it follows the same cut path, but if we look at the laser here, we can see the power is only set to 62, and it's going to go pretty fast at 300 millimeters per second. If we look at the cut path, it's going to be at full power and only 200 millimeters per second. So it's going to go slower, and it's also going to have more power, which means that it's going to go all the way through the material. The scoring will just leave a light score on the top of the material. So we'll hit print here and see how this goes. Okay, so as we can see here, it says it's magic time, so all we have to do is press that button on the Glowforge, and it'll take 4 minutes and 31 seconds to cut all of this out for us. So let's check it out. Now, one very important part of the laser cutting system, as you saw, as it was cutting, it was creating lots and lots of smoke. So one very important part is the ventilation system. So in this custom cabinet that we built here, we have a port for the ventilation hose, and we simply take that, place it outside these doors, and we add an additional fan to be able to pull that exhaust even further away from the building. It does have a built-in fan that is extremely powerful, but we find that adding an additional fan on there will take those fumes further away, and you don't really smell anything. This isn't particularly bad with wood. Where it does get into more volatile fumes is when you're cutting something like acrylic. It's going to produce a much stronger smell that is really unpleasant to breathe. So if you are using a laser cutter, you have to make sure that you are in a well-ventilated space, even if it's indoors, as this one is here. In a setting where there are going to be people around, you have to make sure that it is very well ventilated. Preferably, this would be in a garage if you have one at home. So you're going to have it in the garage and then have that ventilated outside. Again, adding that additional fan just takes the fumes that much further away and dissipates them, so you're not smelling the wood exhaust that's coming off of here, or again, if you're cutting acrylic, you're not smelling the exhaust that's coming off of there. Just like that, we have all of our pieces here. So you can see some of these look burnt, like these pieces here. But if we flip it over, we can see how clean it looks. So the top side doesn't get as burnt as the bottom side does, but what we do use is actually masking tape on there. So if we look at the horn, we can still see the masking tape on there. We can see some traces on the edges here of where it would have been burnt had we not used that masking tape. So if I peel this off, and it's very satisfying to see that clean look underneath. So it gives you that much cleaner look. And for the purpose of the video, I did not put masking tape on the other side so you can see the comparison. So I'm going to go ahead and get this put together, and I'll see you in a sec. And there we have it, our very own custom Grammy Award laser cut right here at the Science Center with our logo engraved right into it. I want to thank you all for watching, and as a bonus today for watching all the way through, we're actually going to be giving this away. So if you're the first one to our front desk here at the Science Center to let them know that you actually watched this video all the way through about laser cutting, this will be yours to take home. As always, I hope you had fun watching today. Most of all, I hope you learned something, and I hope to see you soon here at the Science Center.